All right, so earlier in our previous lesson, we talked about the limit as x approaches a certain value from the left side and then from the right side, and those were called one-sided limits, when it's coming for the left or right side. Now, today what we'll be doing is looking at the limit as x approaches the value from both sides of that certain x value. And we did do that a little bit back here. In this example, we approached 0 from the left side and we approached 0 from the right side. So we're going to now combine those and see what does the function approach from both sides. So we're expanding on that idea of one-sided limits. So let's look at this piecewise function here. So the limit as x approaches 2 from the left side, so I'm going this way, and my x value is getting closer to 2, and my y value is 1. So the limit as x approaches 2 from the left side is 1, and the limit as x approaches 2 from the right side, so if I start on the right side over here, and I get closer to x equals 2, my y value again is approaching 1. So because the left and right limit approach the same value, we say the overall limit exists. So, and that's written like here, the limit as x approaches 2 of f of x is 1. Notice how there's no plus or minus sign right here, because we're saying, hey, the limit from both sides is equal to 1. So if the limit as x approaches a value from the left and from the right side is the same value, then we can say the limit as x approaches that value is the same, is 1. I want to note that this is different from the value of the function at x equals 2. So again, if we're looking at this graph, there's a closed dot down here. So what that means is the value of the function at x equals 2 is 0, but the limit as x approaches 2 is 1. So that is a key difference. We talked about why the limit is 1, because the left and right side limit is the same, but that's different than the function's value. So f of 2 is equal to 0. The value of the function at x equals 2 is 0, but the limit is 1. That is a big difference, and I know it sounds a little bit similar, but I just really want you to understand that those are different things. The value of a function can be different than the overall limit. So now let's look at this function here. We have f of x is equal to the absolute value of x over x. And if the left limit and the right limit are different, then we say the overall limit does not exist. So let's look at the limit as x approaches 0 from the left. So here, as we approach from the left, the limit is, are we getting close to -1? That is the y value where we are getting close to. Now if we go at it from the other side, the limit as x approaches 0 from the right. Follow that? The y value is getting closer to 1. So because these are not the same, obviously these are not the same. Then we say that the overall limit does not exist. The limit as x approaches 0 of f of x does not exist. Or we can abbreviate that D and E. Now the last part, f of 0. So what is the y value when x is 0? Well, that doesn't exist. There's no value for that, because substituting in 0 for x gives us a 0 in the denominator. So it is undefined. So you really need to understand the different notation and what's being asked, because there's 4 different answers here and they all have to deal with x being 0. We have the left limit, the left side limit as x approaches 0 is -1. The limit as x approaches 0 from the right side, from the positive direction, is +1. So since those are different, the limit overall as x approaches 0 does not exist. And f of 0, okay, what is the value of the function when x is 0? That is undefined. Okay, so 4 different answers for those 4 problems. So let's look at the next page here. We have the limit as x approaches 0 from the positive side. So if we come from positive x values, as we get closer and closer to 0, the y values get closer and closer to +1. Then the limit as x approaches 0 from the left side, so if we follow it from the left, our y values again are getting closer and closer to 1. So if we were asked, what is the limit as x approaches 0, we would say that it's 1, since the left side limit and the right side limit are the same. Now this one, next one, the limit as x approaches 4, from positive 4. And there's no positive or negative up here, so we have to look at both sides. So as we get, here's x equals 4. As we get closer to x equals 4 from the left and the right side, we're approaching the same y value of 3. So the limit is 3. So we did not need to write out separately both sides of the limit, because we were able to look at it analytically. All right, now the limit as x approaches -4 of f of x. So here's x equals -4. So if we follow the left side and the right side, we approach the same value of -3. So that's our limit. Now, the limit as x approaches -3 from the left side. So as we get, here's -3, as we get closer to it, the y value approaches -2. Now the limit as x approaches -3 from the positive side, so let's follow that. It also approaches -2. So I want this to say f of -3. So f of -3, what is the y value when x is -3? Well, there's a circle up here at 4. So the value is 4. So the limit, again, does not have to equal the value of the function. F of 0, so when x is 0, I don't see any closed circles or straight lines through x equals 0. So we would say that's undefined. The limit as x approaches -1 from the left side. So here's x equals -1 from the left side. Our y values are getting closer to 0. And then f of +4, again, here's x equals 4. There's a closed dot here at y equals 1, so that would be our value. All right, so I want you to try this problem here. Some of them have limits, some of them are evaluating the function. So pause the video, try it, and once you're done, unpause it, and let's see what you get. All right, so let's talk about these, because I really especially want to talk about these two right here. So those are your answers. Limit as x approaches 1 from the positive side. So here's x equals 1. And if I approach that from the positive side here, my y values are getting closer and closer to 1. But as I approach x equals 1 from the negative side, my y values are going to approach 2, and there's a closed circle there. So since the left and right side limits are different, the limit overall as x approaches 1 does not exist. Then here, the limit as x approaches -1 from the positive side, here's x equals -1, and as I approach that from the positive side, the y value gets closer and closer to 1. Should be 1. Now, the one right below it, the limit as x approaches -1 of f of x overall, there is no left side of the graph here to approach. So the limit does not exist because there's no left side limit there. The limit as x approaches 2 is equal to 1 because here's x equals 2 right there. And as we get closer to that following the graph, the y values get closer and closer to 1. So that's why it is 1. The limit as x approaches 3 does not exist because we don't have a right-sided limit to approach the function. We only have a left-sided one. F of 2. When x is 2, the y value is 2 because we have a closed dot up here. And then the limit as x approaches 3 from the left side, as we get closer to 3 from this side, our y values approach 1. And then f of 1 is equal to 2 because we have a closed dot here. So being able to read and interpret these graphs is going to be super critical when you get to calculus. We're talking about increasing and decreasing in x values and y values. Like, you need to understand, like, the going left and right, that affects your x values, and up and down is your y values. So that's it for our limits from graphs. So you're looking at it from both sides. So thanks for watching. Make sure to like the video and subscribe.